Every problem has a solution, and every solution has beauty. Welcome to Epsilon Edge.
In today's video, we will explore how the Pythagoras theorem can make the interconversion between inverse trigonometric functions surprisingly simple and elegant. Mathematics is not just about solving problems, it's about discovering shortcuts that reveal the hidden beauty of logic. Let's dive in.
Let's draw a right-angled triangle. Here, this angle is called theta. The side opposite to theta is called the perpendicular, or simply P. The side next to theta is the base or ground, shortened as G. And the longest side of the triangle is the hypotenuse, called H. So remember P, G, and H. This is how every right triangle is structured with respect to angle theta. We'll use this triangle to understand inverse trigonometry functions easily. Trigonometric functions are defined based on this right-angled triangle. Here are the 6 fundamental trigonometric ratios. Now, let's look at their corresponding inverse functions. These inverse forms will help us easily convert between different expressions. Let's understand this with an example. We start with sine inverse of 2 by 8. Comparing with sine inverse P by H from the orange box. So in our case, P equals 2 and H equals 8. Let's now use the identity to convert it into a tangent inverse expression. The orange box clearly shows that sine inverse P over H equals tan inverse P over G. To find G, we use the Pythagorean theorem. G equals square root of H squared minus P squared. Now substitute the values, P is 2 and H is 8. H is 8, so H squared is 64. P is 2, so P squared is 4. 64 minus 4 is equal to 60, which simplifies to sine inverse of 2 by 8 equals tangent inverse of 1 by square root of 15. And this is our final result. The identity perfectly connects a sine inverse expression to a tangent inverse. Now, to wrap things up, let's use this beautiful concept to tackle a problem on interconversion between inverse trigonometric functions. Watch carefully, we will solve a problem now. The problem is: find the value of sec of tan inverse y by 2. Solution. First, convert the tan inverse expression into an equivalent sec inverse. From to make it easier to evaluate, sec of tan inverse y by 2. Here, P equals y and G equals 2. So, tan inverse of y over 2, we can actually rewrite this as sec inverse of h over g. By Pythagoras, h equals root of p squared plus g squared. Now, replace p with y, g with 2. Simplify, 2 squared is 4. We use that sec inverse sec x equal x. Therefore, sec of tan inverse y by 2 equals square root of y squared plus 4 over 2. That is the required value.
Stay curious, stay mathematical.